In this video, we generate the dataset of the Gaussian integral and its trendline polynomial and polynomial regression coefficients using ERFC and the norms test. We begin with the definition, the summation of a times x to the power 2n plus 1, where the coefficient a is equal to negative 1 to the power n all over n factorial times 2n plus 1, and the value of n is from 0 to infinity. In this case, we can go as far as 16. And we continue with the coefficient. So our formula minus 1 to the power n all over. There are two parts, so the quantity factorial n. That's the first part. Times the second part, which is the quantity 2n plus 1. 2 times n plus 1. Now we can complete data set of the Taylor-Maclaurin series sum of the Gaussian integral. Our formula series sum of the x values raised to the power 2n plus 1. 2n plus 1 starts from 0. No, starts from 1 because at n equals 0, 0 plus 1 equals 1. So that's the beginning. Now the interval. At n equals 1, this will be 2 plus 1 is 3. At n equals 2, 2 plus 4 plus 1 equals 5. So 1, 3, 5, 7, 9, 11. So the interval is 2. And finally, the coefficient a, which is this column, this area, this range. And we chart this. Insert chart. And we use scatter chart and front row as headers. And series, trend line, polynomial, use the equation as label, and the legend position on the left. So here's the trendline polynomial, but this is not a polynomial, this is linear, so we change that to polynomial. This is polynomial. The series will be polynomial. Oh, we use the 8th degree. Now that's the 8th degree. And we continue with the rest. So the ERFC. So the error function, complementary. So our formula, ERFC of the x values. And this will be our formula, norms test of the x value. And we'll show the equation as label. So that's polynomial. The trend line will be polynomial to the 8th degree. Use the equation as label. Now let's modify. But first we calculate this regression coefficient using Linus. To do that, we complete the Linus matrix, which is transpose 0 to 8. That's the power. And then we enter the elements R formula of the x values raised to the power 0 to 8. And enter. Now we calculate Linus for each. Linus starting with the Gaussian integral, data y, and data x. and the complementary error function. Linus, data y, and data x. Enter. And finally, the norms test. So Linus, data y, and data x. And we'll change this green norms this to change this to green. That's yellow. So the series, the color should be green. Now we're ready to modify the last two formulas. So starting with the ERFC, so this will be negative 1, negative x. And then factor in minus 1, minus 1. Now we're getting closer. Finally, we multiply 0.5 times square root of pi. So starting with zero point 0.5. And finally, the square root of pi. So times square root of pi. Their values, the assets are now the same. The trend lines are all in the same trend line. They're both in the that's the norms disk and the Gaussian integral. And the polynomial regression coefficients are the same. Next, we modify the norms disk. Multiply this by square root of 2. And factor in, add negative zero point 0.5. So minus zero point 0.5 plus. And last, multiply the whole expression by square root of pi. So square root of pi. Now all these are now equal. So their data sets are all equal. They're all in the same trend line. And the regression coefficients are the same. Start with the coefficient of x to the 0, or that 0. This is 0 already because it's 9.24 times 10 to the minus 7, minus 47. Coefficient of x, 0.997. That's 0.997 and 0.997. Coefficient of x squared, 0. Here, coefficient of x squared is 2.22 times 10 to the minus 16. That's already 0. And x squared here is 0. Coefficient of x cubed, minus 0.313, minus 0.313, minus 0.313. Coefficient of x to the fourth, 0. That's x to the fourth, negative 5.07 times 10 to the minus 16. That's already 0. And x to the fourth is 0. X to the fifth, coefficient is negative 0.0696, 0.0696, 0.0696. Coefficient of x to the sixth, 0. Here it's 2.69 times 10 to the minus 16. That's already 0. And here is 0. X to the seventh, negative 6.54 times 10 to the minus 3. That's negative 6.54 times 10 to the minus 3. Negative 6.54 times 10 to the minus 3. X to the 8 is 0. So 0. Here is 3.88 times 10 to the minus 16. That's already 0. And this is also 0. This completes the use of complementary error function, norms test, and Taylor-Maclaurin series sum, Linus polynomial regression to generate the trend line and trend line polynomials of the Gaussian integral.